Okay, everyone, multi-choice in now, so I'm going to go through these quickly as possible. This is chemical tests. Failing solution is a test for aldehydes. This one is an aldehyde, CHO. So that's C. Absolutely no question about that. Just going to get the mark scheme out though. Question 2. Pentane nitrile. Pentane nitrile is 1, 2, 3, 4, 5 with a C triple bond N. You only come across this with as a CN minus as a nucleophile. It's nucleophilic substitution. It's one of our 4 nucleophiles. It's this one here. If you remember that little diagram. Right, next one catches people out because it's a yields question that really easy, I promise, if you just know what's going on. Anyway, if you know what's going on, yeah, that's easier said than done. Propene can be made by propene. Propene can be made from the dehydration of propan. 1-ol. Yep, it can. We know that because you can. Well, you'll know the conditions, don't you? So anyway, you could, that one of these will turn into one of these. That's important, not that you get a 1-to-1 ratio. Right, what is the percentage yield when 30 grams of propene is made from 50 grams? The key thing here is they tell you this 30 grams first, but that's not the important bit. I'm going to put that to one side because that's how much you've formed. With a percentage yield question, there's always 2 parts. Number 1 is work out what you should have formed. And then the second one is what you did form divided by what you should have formed times 100. Anyway, so let's do what you should form. If you've got 50 grams of this, if you divide it by 60, that tells you what you should have formed. I've done the sum somewhere. Got it on my calculator. 50 divided by 60. Where are we now? 50 divided by 60 equals 0.833. 0.833. That means you're going to make 0.83, or you should make 0.833 recurring moles of that. If you then times by 42, you should make 35 grams, but you only make 30 grams, so the yield is 30 divided by 35 is times 100 equals 86. Sulfur dioxide is produced when some fossil fuels are burned. Yes, especially coal. Sulfur, which of the following is true? Sulfur dioxide can be removed from waste gases by acid. Yes, it's called flue gas desulfurization. No, that's not true because it makes acid rain. No, it's an acid, not a base. Sulfur dioxide is ionic. No, it's made of 2 non-metals joined together. None of them. Right, next. Which of the following is a correct mechanism for the formation of 2-methyl-butene? So an alkene from a haloalkane, so it's an elimination reaction. It's this reaction here. Anyway, if that makes any sense. It's this mechanism, elimination. Alright, so I'm looking for this sort of arrow, bonk, 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 bonk. It's one of these, A or B. That is a nonsense mechanism. Nothing ever happens like that. You've not learned a mechanism like that, so why would it be in the exam? That's nucleophilic substitution. That's going to make an alcohol, isn't it? That's going to make an OH here and kick out the Br there, so it's not that either. So it's one of these. So it's just asking you which one's going to make the correct thing. 2-methyl-butene. That is going to put an ene here. Well, that's going to be a 1-ene, isn't it? That's going to put an ene in position number 2, B. Alright, I didn't go into great detail. I don't need to draw the mechanism. It's just process of elimination. So some of you have contacted me about multiple choice, said that you find them difficult. You notice how there are skills going on here. I'm quickly eliminating the ones that are nonsense. That's, I'm better at chemistry than you. You just have to accept that. But it's do this process. You'll do it a bit slower than me probably, but you're seeing what I'm doing. I'm just saying, oh, that's rubbish. That can't be the answer. All right, an organic compound is found to contain 40% carbon, 67% hydrogen, and 53.3% oxygen. Oh, that's setting me up for an empirical formula, isn't it? All right, CHO, 40% here, 6.7% here, 53.3% here. Empirical formulas are so easy. You're going to divide by 12, generally, so easy. Keep saying that, then I'm going to stop saying things are so easy because clearly they're not. Right, 40 divided by 12. So what I'm working out is the simplest formula here. I've got my calculator out on my daughter's phone. 40 divided by 12, that's 3.3 recurring. 6.7 divided by 1 is 6.7. 53.3 divided by 16. 53.3 divided by 16 equals 3.3 recurring. Alright, well clearly this is already, you can see there's a 1 to 2 to 1 ratio. I hope you can see that. For me, that's clear as day. So 1 to 2 to 1. Alright, so which of the following has this sort of 1 to 2 to 1 ratio? Well, ethanol is C2H5OH. That's 2 carbons to 6 hydrogens. It's not that. Ethanoic acid is C2. Hang on, let me draw it out. C, 1, 2, 3, OH. 2 carbons, 2 oxygens, 1, 2, 3, 4 hydrogens. That's C2, H4, O2. 1 to 2 to 1. Just methanol, 1 carbon, methanol, 1 oxygen, 4 hydrogens, methanol. It's not, it's B. Alright. If you find the right answer, don't need to check the others. Generally, if you know it's right. The repeating unit of a polymer. Notice it's a repeating unit, so they haven't got an N and brackets. Right, which of the following molecules would form a polymer containing this repeating unit? Right, to turn a repeating unit into a monomer, you get rid of its arms and you reform the double bond. This is 1, 2, 3. This is methyl propene, D. Right. Okay. 16. A bit of a Maxwell-Boltzmann distribution curve. Typical energy distribution for particles of an ideal gas in a sealed container at a fixed temperature. Which of the following statements is true? Right, position. Right, that's not the mean energy, that's the most probable energy. So position A represents the mean energy. No, it doesn't. Addition of a catalyst moves position EA to the right. No, it doesn't. It moves it to the left. The area under the curve to the right of EA, this bit, represents the number of, yeah, it's that. Okay, it's that. The position of the peak of the curve moves at higher temperature, moves further away from both axes. No, it doesn't. It moves down and flat, so it moves further away from this axis but closer to that axis. It's C anyway. 17. Tetradecane C14H30 is an alkane found in crude oil. When tetradecane is heated, it can crack. Alright, this looks like a bit of adding. How annoying. Right, 14 carbons, 6, 14, 6, 12, 14, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, carbons are right in all of them. 30 hydrogens. 14 plus 8 is 22 plus 8, so it could be this one. 14 plus 12 is 26, 27, 28, 29, 30. What am I missing here? What am I missing? When tetradecane is heated to a high temperature, that means you're going to make alkenes. C5H12 is an alkane. 3 alkenes. Oh, I haven't read the flipping heck. See that? I didn't read the question properly. 1 molecule of hexane. Right, so it's not you. Oh, I'm so silly. 1 molecule of hexane and 3 other molecules. Right, it's that one. 1 molecule of hexane and 3 other molecules. Yeah, it's you. This is 1 molecule of hexane and 2 other molecules. This is 1 molecule of hexane and 3 other molecules, but I bet it doesn't add up to 30 hydrogens. I'm sorry I mucked that one up, or I nearly mucked that one up. See, there you go, real life. Quite late at night, I'm trying to get this done while the kids are in bed. I think I'm tired. But anyway, I'm doing alright. The structure of cyclohexene is shown below. Which of the following is the general formula of a cyclic alkene, such as cyclohexene? Well, I know the answer to this just off the top of my head, but if we just have a look there, this is C6, 1, 2, 3, 4, 5, 6. There's a hydrogen there, there's a hydrogen there. Now this is a carbon with 1, 2, 3 bonds, so it's got 1 hydrogen there, 1 hydrogen there, 2 hydrogens there, 2 hydrogens there, 2 hydrogens there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C6H10. So that is CnH2n minus 2b. Okay, there we go. A cyclic alkane is CnH2n, same as an alkene. And then if you add a double bond, every time you add a double bond, you remove 2 hydrogens effectively. All right, I'm a bit worried about the look of this one because I might come unstuck. If I do come unstuck, I'll have to come back to it later. Right, A and B react together in a reversible reaction. A mixture of 10 moles of A, 10 moles of A, and 10 moles of B were left to reach equilibrium. So that's the start, that's the initial moles. The equilibrium mixture contained 4 moles of B. All right, so that's gone down to 4 moles. What was the total amount in moles of substances in the equilibrium mixture? All right then, so that's gone down by -6. If this has gone down by -6, I'm thinking on the spot here and I'm trying to do it quickly. This will go down by -2 because there's a 3-to-1 ratio. So this will go down to 8. This will go up by 2 to 2, 0 and 0. This will go up by 4. 8 plus 4 plus 2 plus 4, 6, 10, 18, C. I'm doing all right, yeah, nice. Okay, the MR of hydrated copper sulfate is that. Which of the following is the mass of hydrated copper sulfate required to make a 50 centimeters cubed? All right, well, I've got a centimeters cubed and a moles per decimeter cubed. I'm just looking for clues what to do. So this is going to be a C times V over 1,000. I can work out the moles. That's going to be 50 times 0.4 divided by 1,000 to get it into moles per decimeter, into moles, sorry. Right, get my calculator out again. Keeps locking this phone. 50 times 0.4, 50 times 0.4 equals, divided by 1000 equals 0.02 moles. Alright, so I've got 0.02 moles. I need 0.02 moles of that. So, and I've got the MR there. 0.02 MR times, this is moles. If I times the moles by the MR, this is the MR. This is moles. Moles times MR equals mass. Times MR. Got 0.02 on my calculator. Times MR. 249.6. 4.99 D. 20 is D. Yay. Okay. Next. So honestly, I haven't seen these questions before, and you'll know in the multi-choice you don't get any working out, so I might make a mistake here, you never know. Right, questions 21 and 22 refer to the production of hydrogen by the reaction of methane with steam. The reaction mixture reaches a state of dynamic equilibrium. Okay, that's when the rate of the forward reaction equals the rate of the backward reaction, and you get no further change in concentrations of products or reactants. It's an endothermic reaction, which means that energy is taken in. Which of the following shows how the equilibrium yield of hydrogen and the value of the equilibrium constant are affected by the changes shown? First thing to note then, the only thing that changes equilibrium constant is temperature. That's a real thing that you try and catch you out on. The only thing that will change an equilibrium constant is temperature. So so any other one that says it will change the equilibrium constant is not true. Pressure does not have any effect on Kc, so it's not U. Removing something has no effect on Kc, so it can't be U. So it's between adding a catalyst and increasing a temperature. Adding a catalyst will do nothing to the equilibrium yield of H2. You'll just get there quicker, so it's not U, so it must be U. C. 21, C. Doing all right here. All right, you can check it if you like, but that's because all the other ones were nonsense, and it came down to this. The only thing that affects equilibrium constant is temperature. So you shouldn't have looked at A or D. All right. Right, 22. Some enthalpy data is given in Table 3. Use the information in Table 3 and the stated enthalpy change for the previous question, plus 206, to calculate the missing bond enthalpy. Right. CH4. I'm miles ahead of schedule here in the exam, so I best not panic. All I'm saying is I've got 23 minutes of time on my video before my memory runs out. CO, that's going to be a triple bond O, that's the one that's missing, and 3 H2s, that's H2, H. Okay, right. Energy required to break all those bonds, energy required to break all those bonds. This is going to be 4 times 413. That will help me break this bond, this bond, this bond, this bond. I recommend you do this, by the way. Energy required to break this bond and this bond. That's 2 OHs. That's 2 times... where are you? 2 times 463. This is X to break that bond. So that's X. And this is 3 lots of 400. 3 lots of 436. And all of this equals plus 206. So I would write this, I don't know if you did it the same way with Dr. Halliday. I would say that this gap plus, I'll write it down here, plus 206 is the same as going with these two numbers equals 4 times 413 plus 2 times 463, and then against this arrow, so minus X and minus 3 times 436. Plug in those numbers, I haven't got time to do it. 22 is B. Right, last question. 2 moles of ideal gas X. Don't be freaked out by ideal gas. Ideal gas means a gas that behaves perfectly according to the laws of physics or whatever. That's not the actual definition, by the way. Most gases are close to being ideal gases. So anyway, don't worry about it. 2 moles of a gas X are stored in a flask of fixed volume. Which of the following changes would lead to the greatest increase in pressure inside the flask? Oh God, sounds very physicsy. So you've got a flask, you've got 2 moles of X in here, it's sealed. All right, if you increase the temperature from 20 to 200 degrees C, so you've got to think, where have you... it's got to be PV equals nRT in it. PV equals nRT. Right. You could work out the pressure at 20 and the pressure at 200. Pressure at 20 equals nRT over V, and you could plug in... it's not 20, it's Kelvin. Is it Kelvin? Do you have to do Kelvin? It's my first, my first blip. It's PV equals nRT in Kelvin. Tell you what, it doesn't matter, because that's going to be a 10-fold increase. You're going to get a 10-fold increase in pressure. So that's going to be times 10. Because if you look at this equation here, if you have this number as 20 or whatever, and then the next time you have it as 200, it's 10 times 10-fold. Is it that simple? Anyway, add another mole of gas into the flask. So if you change this from 2, moles is N. If you change it from 2 RT to 3, this would change it to nRT over V. So you could have 2 RT over V, or you could have 3 RT over V. I'm thinking that's a 1.5 times increase, maybe. If I'm miles off here, physicists, you can pick holes in this, or anyway, chemists as well, pick holes in this later. I don't really care, I want to go to bed. Adding 0.5 moles of argon gas and increasing the temperature. Adding half a mole will change the number of moles from 2 to 2.5, so you'll go from 2 RT over V to 2.5 RT over V. And the temperature will go from 20 to 150. 20 to 150. That's a fairly big increase, isn't it? I'm missing a trick here. I'm annoyed that I don't know if that's in Kelvin or degrees C. I don't know if it makes a difference even. So that's the temperature in here will be 20. 2 times R times 20, and this will be 2 times R times 300. You know what? I'm just going to Google quickly whether... It's the only question on the old paper I've got a bit stuck on, and I think I could have a very good guess anyway. PV equals nRT. Is it? It's all about the units, that, innit? PV equals nRT units. Come on, phone. I'm on my daughter's phone again, and it's a bit slow. It's too slow. It's too slow. Okay. Right. This one then. I'm just typing it in now. PV NRT units. Comes up first thing you search on Google. PV equals NRT units. So this one adds a little bit of gas. Oops, this one adds a little bit of gas and then bumps the temperature up. I think that's going to have quite a big effect. This removes a bit of gas and then massively increases the temperature. Not massively. It is Kelvin, isn't it? It's Kelvin. Does that make a difference? So it's not just 10, it's not as simple as 10 times. Right, I'm going to do it again. You can stop the video now if you want the answers to see. I've just looked. Right, I'm going to keep working away at this. So for A, you would go from NR times to 297 to NR times. It's not as simple as timesing it by 10 because it's not. Yeah, it's not 10 times hotter. 20 degrees. 200 degrees is not 10 times hotter than 20 degrees. And that is 200. What am I doing? 297. 293.7. I'm mucking up here. 200 plus 273. It's up to 400. And it's very important, this, isn't it? 473. So that's not a 10 times increase. That's about a double. That's about a doubling. This one's about a 1.5. This one we've already discussed is it times a 1.5 and then increase the temperature. So that's going to have quite a big effect. And this one is again, it's about a doubling. All right, I made a bit of a meal of that. I think I'd have got there in the end. In the exam, I'd have plumped for Kelvin because I remember that this one is like a physics equation. We're using meters squared instead of centimeters squared. Blah, blah, blah. I'm digging myself out of a hole. All right, I hope you enjoyed that. If you sat through all of these videos, good effort. All right. See you soon.